All right, guys. The next section is the regular payment of an annuity. It's often useful to calculate what the regular payment, that would be R in our formulas, would be for an annuity. And we may have to, well, I'm going to specify that we're going to have to use it with the one with the A and the one with the P, both formulas you've learned so far in this chapter. So the way that you tell this is you use the amount formula, the first one that we did. I think that was section 7.1, to determine the accumulated value of regular payments at the end of an annuity. And you use the present value formula to determine money needed at the beginning, that's a key word, of an annuity to provide regular payments. So, example one, at the age of 25, you start saving for retirement. I don't know what that question mark's for. Your goal is to have $1 million saved by the time you are 55. If interest is 3.6% compounded monthly, how much should we invest each month in order to reach our goal? So we know we want the principal to end up being $1 million. We want to find what that regular amount is that we need to invest if the interest rate is 3.6%. So that's 0.036 divided by 12 because it's being compounded monthly. So this is going to be tricky. I don't have my Casio here. I'm going to have to go with the cell phone calculator. So 0.036 is the 3.6% in decimal divided by 12 gives me 0.003. The number is going to be 12 times per year times how many years? What are we starting at? 25 and we're going at 55. Oh, good. So it's 30 years exactly. And I can go 12 times 30, not a big deal. So that's 360 for my N. Okay, so we have to go to our formula. It's going to be the one with the P in it, or the A in it. We want an amount later. So let's review that. We go back here. It's the one with the positive exponent. We're looking right here because we want an accumulated value at the end of the annuity. We want $1 million at the end, all right? So we go A equals R. R bracket 1 plus I to the power of N minus 1 over I. All over I. So we're going to put $1 million in. The color's starting to bother me again. I don't like that it defaults to red. What's yellow look like? Not bad. So that's going to be $1 million equals R. That's what we're trying to solve for in this case. Bracket 1 plus the interest rate, that's my 0.003 to the power of 360 minus 1, close up my bracket, all divided by 0.003. So, I mean, you could rearrange this and isolate for R before you begin, but you can actually figure out all this stuff on the right side beforehand. So I'm going to attempt to do that right now. So in the brackets, I've got 1 plus 0.003. So I go 1 plus 0.003 is 1.003. And now I'm going to have to flip my cell phone calculator to sideways, and I'm going to go to the power of 360. 360 and hit equals, and it gives me 2.939922536.1. I'm not going to write that down because right after that it says subtract 1. So I subtracted 1. So just to show you what I've got on my calculator, I've still got my million on the left. I've got my R. So I figured all this stuff out here, and it worked out to be 1.9399 and a bunch of other stuff. Before I'm done with this side, I got to divide that number by 0.003. So I'm going divided by 0.003, which makes, I've got 1 million still on this side. 1, 2, 3, 4, 5, 6 equals R times 646. 646 decimal 64. And there's some other stuff. I'm going to leave that number there as long as I can. Next, I have to divide that over on the left side. So my regular payment's going to be $1 million divided by 646.64 basically. And I'm going to type that in now. 1 million, 1, 2, 3, 4, 5, 6, divided by 646.64. So at age 25, if you could put away $1,546.46 each month, you'd end up with $1 million at age 55. And that interest rate, it's good, but it's not unrealistic. I think the problem is, and the reason I don't have $1 million, or I won't by the time I'm 55, is not very many people at 25 can afford to invest $1,500 into an investment and stick with it for 30 years. If you do, though, you'll be a millionaire, 100%. All right. Now let's look at the other version, the one with the negative exponent, the one I'm less good at. It says a scholarship's been established and is currently worth, so you got $25,000 in the bank. Every year for the next 25 years, the school wants to give out an equal portion of this money for the scholarship. If they're earning interest at 2.3% annually, how much is the scholarship going to be worth each year? So we're trying to find R. This is the P is going to be the 25,000. But this is how much we have now in order to provide us with these regular payments. The interest rate is 0.0235, and it's annually this time. Yep. So I can leave it like that. I don't have to divide it by 12 this time. It's not a monthly payment. This is a yearly payment. And the N is 25 years and just once a year. It's annual. I'm so used to doing it monthly. Keep wanting to divide by 12 or 4 for quarterly, but it's yearly, so I don't have to change any of that. So this is the one with the present value, or P equals. Let's go back and have a look at that formula and find the one with the P. It's the one here at the bottom. It's R and 1 minus 1 plus I. R and 1 minus 1 plus I. 1 minus 1 plus I to the power of negative n, close the bracket, and it's all over I. Let's go back and make sure we got that right. Looks like it is. And now let's substitute in there. So I got $25,000 equals R. That's what I want to solve for. 1 minus 1 plus that interest rate, 0.0235 to the power of negative 25, close up that bracket, divided by the interest rate of 0.0235. Looks a little ugly there, my 5, that's 235. So again, I would recommend you work out that stuff on the right before you start dividing things around. So that's what I'm going to choose to do as well. So I'm going to do that bracket first, 1 plus 0.0235, hit equals, and it's 1.0235, of course, to the power of negative 25. And that gives me, I'm just going to tell you, 0.559 and some other stuff. So that's what this whole chunk here gave me. Now I have to go 1 minus that. And I'll just show you what I have. 25000 equals R bracket 1 minus, and I've worked all that out there to be 0.5595. And then I got to divide the whole thing by 0.0235. All right. So I go 1 minus 0.5595 equals, and it's 0.4405. And I'm going to divide that 0.4405 by 0.0235. It equals, and it gives me 18.744. I'll write that down. 25000 equals R times, I've got it right to one number, 18.74468. So all I have to do now is divide that over there. It's going to be 25,000 divided by that 18. And I'm going to type that in now. 25000 divided by 18.74468 equals, and it gives me a regular annual payment of $13,333.71 is what the annual scholarship would be worth. Not too bad. Anyway, that's how you handle that. Now, the next slide, I believe, is blank. That's because this is where the picture of the textbook pages would be. But they didn't upload to Google Photos fast enough for me to do this lesson. So I will make sure that they are attached to the posting. They'll be just image files. And I only want you to do numbers 1, 2, 7, and 8. So 1 and 2 are just basically rearranging those two formulas and using your calculator. 1 and 2, punching those numbers in, it can get a little difficult. And then 7 and 8 are word problems like you just saw. I think that 7 is just like the first example. I did look at them and pick them specifically for this, so hopefully I got it right. And then number 8 is just like the second example that we did today, okay? Watch for monthly or annually to see whether or not you have to divide the interest rate by 12 and multiply the n by 12. So just be careful with that. Email me if you have any problems, and just submit your solutions to these 1, 2, 3, 4 questions. And good luck with that, guys. We're almost to the end here. And hopefully this goes well for you, okay? Email me if you have any problems, of course. All right, good luck.